Hello everyone, welcome back once again. Thank you so much for the comments and the feedback on the previous videos. In today's video, we're going to discuss about the continuation of what we studied in the last class. That is, let me remind. So we studied about the percentage composition and also how to calculate the atomic weight. So today we're going to discuss about the very important concept of the stoichiometry, that is mole. When we are talking about the gas or any element, we measure in the unit called mole. So that's what we're going to discuss. So before starting the class, if you haven't subscribed to my channel, please subscribe to the channel and click on the bell icon. So whenever we upload a new videos, you will be notified, and also share to your friends so they all also can get like benefited of it. Okay, so let's get started. Before starting with what actually the mole is, let's try to understand what is atomic weight and how they are related in terms of grams. Because mainly when it comes about in terms of calculations of moles and all, we need to represent the element in terms of grams rather than writing in terms of atomic weight. So if you relate, as you can see here, the atomic mass of an element, which is also called it as AMU, is the same as the mass in gram of 1 mole of an element. So what we are trying to say, atomic mass unit is same as the mass in grams of that particular element. For example, atomic mass of chlorine is 35.4527 atomic mass unit. Thus, 1 mole of chlorine atom would weigh 35.4527 grams of in terms of mass. So indirectly we are saying atomic mass unit is equivalent to the gram. So if you have any confusion, what is this? We are representing 1 mole of chlorine has these many atoms or something. Just try to understand atomic mass unit is same as a mass in terms of grams, and that we use to calculate the moles of this element, mole of substance, mole of gas, whatever we're gonna study. All right, so that just keep it in mind. Weight is equivalent to the mass in grams. Let's start with the mole. So mole is an important factor which we use while doing calculations in chemistry. That is mainly which whenever we are dealing with the stoichiometry, everything we have to represent in terms of moles, whether it is a molecule, whether it is a substance or anything, we have to write it in terms of mole. So, but what actually a mole? When we say mole, it's just a number like a dozen. When we represent dozen is 12 in count. Similarly, the mole means 6.02 into 10 to the power 23. This number is also called it as Avogadro's numbers. Now, what Avogadro's number says, let's try to understand. So, for example, if I say helium's atomic weight is 4 AMU, that is atomic mass unit. So, 4 gram of helium contains 1 mole of helium atoms. So, when I use the word 1 mole of helium atoms means 4 gram of helium has 6.02 into 10 to the power 23 number of atoms in it. So that is the meaning of mole. So mole says like how many atoms present in the particular element of atomic weight or element of certain mass in grams. So similarly, when I say 8 grams of helium contains 2 mole of helium. So now how many atoms it would have? I just will be multiplying 2 times 6.02 into 10 to the power 23. That many number of atoms the 8 grams of helium will have in it. So similarly, we know atomic mass unit of a carbon is 12. So 12 gram of carbon, there is a 1 mole of carbon atoms in it. So we can say 12 gram of carbon has 6.02 into 10 to the power 23 number of atoms of carbon in it. So that is how you measure the mole in terms of mass and in terms of atomic mass unit. It just says how many atoms present in it. All right. So then when it comes in terms of conversion, how do we do that? So you can see here about the conversion. So whatever the substance they give it, whatever the atomic weight, whatever the mass in grams, and when they ask us to convert that in terms of mole, this is what we're gonna follow. So the number of mole is equivalent to mass in gram divided by atomic weight. Just remember this rule while converting the mass in terms of a number of moles. We will be using this. Of course, I need a periodic table when they ask me to convert the number of moles, because I need to know the atomic weight of the substance or element what we are talking about, mass in, and accordingly we can relate that how many moles of that substance which is asked in how many grams. So that's generally we use this equation to solve it. In general, when they ask me any calculation in terms of mole, remember this. So mass in grams divided by atomic weight. So let's see some of the examples related to it. These are the common ways of asking questions about the mole conversion. So let's take here, how many moles of oxygen molecule in 64 gram of oxygen gas? They're asking us how many moles of oxygen molecule in 64 grams of oxygen gas. Let me tell you, we are talking about oxygen molecule. And how do we write the molecular formula for oxygen molecule? O2. Now they are saying that if 64 grams of oxygen molecule has how many moles of oxygen? So to convert it, I need to know what will be the atomic weight of oxygen molecule. As we know that the number of moles, as we just say, number of mole equal to gram in mass in gram divided by the atomic weight. That's what we mentioned, right? So atomic weight, so 64 grams represent the how many moles. To do so, I need to know what is the atomic weight of oxygen, and for doing that I need a periodic table. When I'm saying O2, it means there are two oxygen atoms are there combined made oxygen molecule. And what is the atomic weight of each oxygen atom? That we will be getting it from the periodic table. So you can see that atomic weight of oxygen is 16. So you can refer here, atomic weight of one oxygen atom is 16. So we have two such atoms. So we can say the atomic weight of oxygen will be 2 times 16, which will be 32 atomic mass unit. And we also mentioned atomic mass unit is equivalent to gram. Also we can say O2, that is, the O2 oxygen molecule has 32 grams, and now while calculating the mole, substitute it. So 64 grams, as they have mentioned to us, is equivalent to how many moles? So we can say 64 divided by the atomic mass, which we calculated as 32. So we can say half of 64 divided by 32, that gives us 2 mole. So we can refer 64 grams of oxygen gas has equivalent to 2 moles of oxygen gas, and that's what we go with option B. So these are the common way of asking questions. Let's take example 2 here. 200 gram of sodium chloride is equal to dash mole of sodium chloride. They want us to represent 200 gram of NaCl is equivalent to what amount in terms of mole. As we have a definition again, the mole is equals to grams divided by atomic weight. So how do we calculate here? Mole of NaCl equal to 200 gram divided by atomic mass unit. So I can say atomic weight of NaCl, atomic weight of sodium chloride. So we just need to calculate what is the atomic weight of NaCl. So how do we calculate that? By referring to the periodic table. As we know, NaCl has 1 atom of sodium and 1 atom of chlorine. So Na, what will be the atomic weight of sodium then? Atomic weight of sodium, here you can see that, which is 22.99. So which will be written as 22.99. And similarly, atomic weight of chlorine is 35.4527 something. So here we are given in the periodic table as 35.45. That's what I find. Sodium is here, and the chlorine, which you can see that 35.45 as its value. So to get the what is the total atomic weight of this, I just need to add them. So this is gonna be 22.99 plus 35.45. So when we add them, what will be the result? We're gonna get it as, add them and check it up. Simple, at 22.99 plus 35.45. So that gives us the result as, convert into decimal, 58.44. So we can check it, take it as 58.44 atomic mass unit. So which is also equal to 58.44 grams. So we can say 1 mole of sodium chloride is equivalent to 58.44 grams of sodium chloride. So we can say 58.44 grams. So now we are asked to calculate 200 gram is equals to how many mole. I just need to substitute here. So 200 divided by 58.44. So whatever the result we got, the 200 divided by that. So in this case, what we gonna go? 200 divided by, so 58.44, which is divided by answer, that gives us 3.42231 something. So which is equivalent to 3.422 in terms of mole. So which is equivalent to option B. So this is the way of calculating. This is just an introduction to how do we calculate the mole for the given substance in terms of whether it is in atomic weight or in terms of gram. And this is the very fundamental we need to know about the stoichiometry. In the next videos, we will be going with the more advanced of it, based on like how do we do the mole calculations and other stuffs related with that. All right, so till then, this is the what we supposed to do in today's lesson. I'll be meeting you guys soon with the next videos. Thank you so much.